Good morning, ladies and gentlemen. My name is Mohammed Salih Ibrahim, PhD student at Eurasian University, Institute of Applied Medical Sciences. Today I'm going to present a paper on evidence of oxidative stress in experimental rats that are exposed to the use of D-transalkyl mosquito-coil insecticide. First of all, these insecticides are being used in order to take care of a vector of malaria. So briefly, what is malaria? Malaria is a life-threatening disease that caused by parasites that are transmitted to people through the bite of infected anopheles mosquitoes, the female one. It is preventable and curable, one of the good news. You see this Plasmodium parasite, there are 5 types of it, and 2 of which are falciparum and vivax. The most prevalent malaria parasite in the African continent is as a result of Plasmodium falciparum, and P. vivax is the dominant malaria parasite in most countries outside the South African region. In 2018, an estimated 228 million cases of malaria occurred worldwide. And most of these malaria cases in 2018 were in the World Health Organization region, followed by the World Health Organization region of Southeast Asia region with 3.4% of the cases, and the whole Eastern Mediterranean region with 2.1%. 19 countries in this Sub-Saharan Africa and India carry almost 85% of the global malaria burden. 6 countries accounted for more than half of malaria cases worldwide. For example, look at Nigeria, 25%, Democratic Republic of Congo, 12%, Uganda 5%, and Cote d'Ivoire with 4%. Take a look at the chart. You will see from 2008 to 2018, from 10 to 2018, Africa is having the highest number of cases compared to other regions. And take a look at this estimated country share of the total malaria cases of P. vivax malaria in 2018. You will see out of 100, in 100%, Nigeria is accounting for the highest percent, which is 25%, followed by Democratic Republic of Congo with 12%, then Uganda, Mozambique, as you can see. And the percentage of estimated malaria deaths attributed to 21 countries with nearly 85% of malaria deaths globally in 2018, Nigeria is accounting the highest percentage, that's 24%. This is telling you that worldwide Nigeria is suffering mostly from this disease. It's having the highest number of deaths and highest number of cases. Take a look at this chart. In 2018, there were an estimated 405,000 deaths from malaria globally, compared with 416 deaths estimated in 2017 and 585 in 2010. And one of the biggest threats of this disease is that it is the leading cause of death among children below the age of 5. The mortality rate, the death rate of children below the age of 5 is very, very high. 65%, 67% of all the malaria deaths worldwide is within children below the age of 5. So now, how can we control the malaria? Usually there are 2 ways to control malaria. It's either you control the vector, that is before it even causes the malaria, or you wait for it after it happened, then you take care of the plasmodium. According to the World Health Organization, the best way to control malaria is to control the vector. So various ways in which you can control the vector is by the use of insecticides. My country is suffering from this disease, and the highest number of cases and deaths globally is Nigeria, the percentage. So because of that, so many people are using all the methods, all the necessary things they need in order to take care of this malaria. And one of these insecticides that are used is a mosquito coil called antelope, which is manufactured in Nigeria by Merchant Investors Limited, which is situated in Ogun State. This insecticide consists of an ingredient called pyrethroid, and specifically it has what we call D-transallothrin, which is 0.2% impregnated in this mosquito coil. One of the problems that takes our attention, we scientists, in order to look at this, is that this D-transallothrin is not yet been approved by the World Health Organization. So its safety, it's really something important for us to look at. So in order to fill in these gaps, establish if this D-transallothrin based mosquito coil is safe for human use, we export experimental rats to smoke from antelope mosquito coil with different exposure times, and then we establish markers of objective sex with experimental rats compared with control rats. Though the efficacy of antelope coil in deterring mosquitoes is established, we don't know of the human safety due to exposure with the smothering smoke of this mosquito coil. The method we use, we make use of experimental rats, and this is the weight, 110 to 150 grams. We make use of them, and these rats were kept under standard housing conditions in a metal cage at a room temperature and 12 hours light and day cycle. They were allowed to access to drinking water and laboratory standard diet. And the design of the experiment, briefly, the rats were allowed to acclimatize before commencement of this experiment. The rats were grouped into 5 groups. We have group A1, group A2, group A3, and group A4, and then group A5, in which group A5 are used as our control group. These rats were kept in separate cages, and this is the specification of the cage. Group A1, A2, A3, and A4 were exposed to this insecticide through whole body inhalation for 15 minutes, 30 minutes, 1 hour and 2 hours respectively. As I said, group 5 served as control and was not exposed to the smoke. The smoke exposure box was constructed which consists of a ventilated smoke generating chamber, which is an acrylic cylinder radius of this specification, and a whole body chamber of this specification that are connected serially via silica tubes similar to the method used by this scientist. The rats were treated for 4 weeks. On the 29th day, rats were sacrificed and blood samples collected. The blood samples were centrifuged and the serum was separated and used for biochemical assay. These are the results, and this is the result, and this is what we got. You see, in our research, we try to check serum melinda-aldehyde because melinda-aldehyde is a marker of oxidative stress, and then we try to check serum bilirubin and alkaline phosphatase. Why are we checking these two parameters? Is because we want to see if there is any damage to the liver cells, integrity of the liver cells and the hepatobinary system. And that is why we decided to include bilirubin and alkaline phosphatase. And the DLOFST is the dry layer oxidative stress, is also an oxidative stress test. A1 were exposed for 15 minutes, A2 for 30, A3 for 60, A4 for 120, and that the control group, that the ABAP, they were not exposed. Comparing the serum melinda-aldehyde level of group A1, A2, A3, and A4 with the control group, there is a significant increase. There is a significant increase. But for serum bilirubin and alkaline phosphatase, both of them, there is no significant difference, no change. There is no significant difference when we compare it with control. But for the dry layer of oxidative stress, a significant increase is seen when group A1, A2, A3, and A4 were compared with the control group. This is to show you the serum MPA of these groups, and as you can see, this is the control group, and this is A1, A2, A3, and A4. If you look at that, it's a significant decrease in the level of malondialdehyde. And this is the dry layer of oxidative stress. We carried out this test by the use of microscope with an we take the whole blood of this animal on a glass slide and review it under microscope using an immersion oil. If you look at group A is experimental rats from group A1, the B from A2, C from A3, and D from A4. Take a look at this. If you see protein puddles, it is telling you the presence of oxidative stress. So A and B, you can see a mild stress, but C and D, we can see the crack in the blood with the protein puddles shown in the blood, which is telling you that this rat in this group suffered from the highest oxidative stress due to the exposure time of this mosquito coil. And this is the control group, as you can see. There is little or no oxidative stress. So exposure to this mosquito coil results in significant increase in this MDA level in this rat compared with the control group. And why are we seeing this? Because MDA is an active aldehyde which is generated as one of the products of lipid peroxidation and the most widely used index of lipid peroxidation. The increase in serum MDA from A1 down to group A4 may be due to increased exposure time that leads to production of more free radicals, which increase lipid peroxidation and eventually increase in the generation of this active aldehyde, which is the MDA. So, in conclusion, this oxidative stress is not a disease on its own, but it is a condition that can accelerate existing diseases. Complete liver function test should be carried out, as this will provide a more insight about the detoxifying organ. Antioxidant test should also be included in the next research, especially vitamin E, and also markers of oxidative stress like glutathione and also 4-hydroxynonenal should be carried out. And furthermore, the safety of the antelope coil should be investigated in those humans that are using this mosquito coil. So, thank you for listening. If you have any questions, please do not hesitate to ask. Thank you very much.
No?